Well, welcome to Open Lab, folks. This is for the Design 330 crew, and here I am in the lab, and ready to see me do a little demo of the part material log, which I added on. I forgot to put into the assignment, so I added it in yesterday. So I'm going to go ahead and move myself out of the way here, and we're going to open up the part material log. Now, what this is very typical. You've got just a list of numbers. Sometimes they mean something, sometimes they don't. You have some descriptions of parts, material specs, and often you'll have a particular part made out of three or four different materials: bronze, brass, steel, stainless steel, cast iron, plastic. And so often people do different things with the numbers. Sometimes they just copy and paste it and put a new material in. That's one common way. And sometimes they just add another one of these, insert a row, and they would copy this, and that would be um, try to get this right. Something like that, where they add it in. We're not really going to worry about that right now. I just want to get you comfortable with the fact that part numbers, they're just assigned by somebody. And when an engineer or a designer creates a new part, it's a part that has never been made or used in that particular company or that particular design group. You need to give it a part number, tell what it is, tell the material, and it might be made from something. So now let's take a look at one of these gears. We're going to talk about this one in particular. This is the pinion gear for our gear set. And in this case, it's made out of steel. That's what we've said. Now, the ones that I've 3D printed, of course, are made out of plastic. But often it's going to be made out of steel. Maybe it's an alloy steel. We'll talk about those maybe in a little while. Maybe it's aluminum or bronze. There's lots that goes into the choice of material that depends on the maintenance and the wear and which gear you want to wear down faster than another gear. And if it does break, which one should break. All sorts of interesting stuff. Okay. But then you'll notice that, this is the gear data. And then I did something special to it. I made my own um, shaft inset, right? I made my own place for the driver to go in, and it's non-standard. And then I put some holes on it. And nobody's written to ask me what those holes are for, but they're insets for thrust pads. Gears always move back and forth and back and forth. They never stay exactly where they are. So if you do not have bearings that take the thrust, you have to make some. And so I suggested, well, I'll just find out and see. It's not really included in my design, but I put in some spots for some little pads, wear pads, thrust pads. So if I want to, I can put them in there. So those all have to get made. And in this case, if this were steel, the way it would be made is you would go out and buy the gear blank. These get made by the thousands, and they're very inexpensive. And then in your shop, you would add these things. So this is a gear machining drawing. The drawing is really mostly about where do I put this? Where do I put these holes? How do things have to line up? Uh, how flat do they have to be, things like that. And then how do I take care of it after I've made it? Okay, and so I have a parts list that says this gear that you see right here is made from a gear blank. Made from a gear blank. I just go to the stock room, I pull one of these gear blanks off, I set it on my machine, probably a mill, and I mill away all the parts, that don't want the gear blank normally does not have these features in it. It's a solid steel gear. No hole, no nothing. Okay? So if I were a purchaser and I go, hey, we're going to have to make 10 of these things, I'd have to go out and buy 10 gear blanks. So how do I do that? I go to my material log. There's my gear. And I'm going to make it from this gear blank, 330.11. So I'd go to I'd have to get this gear blank. Okay. Now, from this gear blank, I might also make something with a round hole or a square hole, or without these, or with a spline, or a through hole, or a countersink. I mean, oh my gosh, that's what design is about. Take something that you know and then modify the design for your own use for this particular need. Okay, so in this case, I've also put down corner relief. In other words, if I had a nice hex that had sharp corners, I'd want to make sure that it doesn't interfere, right? That like when I make this, it might have a little round spot on it. So I drill it out. I drill it out just a little bit so that when my piece goes in there, those corners are always a problem for making them fit. Okay? So I want to make it from a gear blank, and I'll do my thing for this particular design. Okay, so this particular design is made from a gear blank. And if I make a different design from that gear blank, I'll put it down here. Okay. So now it's important to know, because in your shop you might have, 100 gear pinions. So we want to know about this gear pinion. We want to know the OD, 2.5, and the pitch diameter, 2.3. So the OD is 2.5, and the pitch diameter was 2.30. I think I got that right. Yep. And then the root diameter. Oh, let's see what else. The DP. I want the DP. The DP was 10 on this one, and the pressure angle was 20, and my number of teeth were 23. And the face, that should have a colon after it, by the way, was 1.00. Now I know about that one. And if I need another gear that size, I can go get it. Now, for here, I can actually, all of that stays the same, right? Because I didn't touch it. So I can copy that down and just call this a gear blank. So that's my gear blank. Now, the reason I'm putting these colons in is that many programs look for specific characters, and then you export it, and it breaks it all up the way it wants. So I was taught early on that you put a character, and then your computer program that will read your log can break it up like it wants. So it doesn't really matter what that character is. But I got trained that we use colons or bars or dashes, something like that. So that's how you do this. Now, in this case, in my design, I'm going back to my design, it was steel. So I'll just put steel. Now, I might need more than that. There are many, many types of steel. And you may have done some work with that in your previous classes. But you would want to know what kind of steel you're using. Gears are usually an alloy steel, which means there's other stuff in it. And so a real common one is 4140. And that's an ASTM number. Let me make that fit. There we go. 4140. And that's a real common steel that's used on gears. This tells you about how much carbon, how much molybdenum, how much other types of things that are in there. So the 41 series means that it's the 41 series tells you that it's a chrome moly alloy with 0.4% carbon in it. So there's mostly steel. There's some chromium and some molybdenum in certain ratios. Mostly iron with chromium and molybdenum, and then that's the amount of carbon. If you're interested, you could look up alloy steel naming standards, and you'll get reams of stuff on all this. Okay. Now, I didn't really learn all that when I was in college. When I started working in the shop, I looked through this list and I saw all this 4140, and I go, oh, I better learn about that. And it's a very good steel. It's very durable, which means when you hit it or put force on it, it tends to not move very much. And when you try to wear it with friction, it tends to be very, very good with friction. It's also got a variable hardness. In other words, you can heat treat it to go from soft, annealed, to hard, heat treated, basically. So it can go from soft to hard. It's durable. It's got good impact resistance. So people like it. And that means this blank would be from 4142. Now, the driven gear might be something else, right? The loads on a driven gear tooth, if it's bigger than the pinion, allow it to be made out of a different material. If you use a different material, you avoid something called galling. Okay, and like materials, when they rub on each other, tend to gall. And so good practice is to use different materials. So maybe instead of a 4100 series, you would use a 10 series, and you would use a 1020 series or something like that, which it's just different enough that it won't do that. Or maybe you'd even go to a brass or a bronze, but you would look at that in your good old inventor to see what kind of loads it can take. But let's just, for us, say that those are also going to be that. Okay? And so now, if I put a gear set together, if I know that I want a ratio of 4 with a certain center distance, let's say 3, then I can use this and this, right? My 10 and my 12. Okay. And that's kind of cool. So if I want to have an alloy steel one, or I can just say per part number. Okay, that lets me mix and match a little bit, and all I have to do is call out which two I want. But now I can look. I can do filter, Control F. I can do, yeah. Hold on a sec. I can do a ratio of 4, and then it'll call that up. Okay, so that's a little bit about how to do this one right here. All right, there we go. Hopefully that gives you a little bit of information on how to do the material log. We're going to continue doing this. Every part that we draw, we're going to put into our material log.